In this video, we're given a problem such that the third term of a geometric series is 324 and the fifth term is 36. We want to find the first term and the two possible values of the common ratio r, and then B says given that r is positive, find the 11th term of the sequence. So we're given two key pieces of information, so let's write out what these are. First of all, in part A, we're given the third term u3 is equal to 324. We're also given that the fifth term u5 is equal to 36. Now, let's think about what this sequence actually means. Well, really our sequence is built up that we have our first term, second term, third term, fourth term, fifth term, and so on. But what are our terms in our sequence? Well, our first term we would say is A, that represents our first term. Our second term is A multiplied by an R, so you've got AR. The third term is then multiplied by a further R, so in other words we have A times R squared. The fourth term is A multiplied by a further R, so AR cubed. And the fifth term would be AR to the 4, and so on. So we can use this to help us. If we have the fifth term and the third term, we can have ourselves a ratio there. If we have u5 over u3, well, really, in terms of A's and R's, that represents A to the 4 over AR squared, which really simplifies down to R squared. Well, we know this is R squared, but we can also write this numerically because we have values for u5 and u3. So we can say that this is 36 over 324, which then simplifies to 1 over 9. So from this then, we found that r squared is equal to 1 over 9. But we don't want a value for r squared, we want a value, or in this case, two possible values of the common ratio r. So to get rid of the squared, we square root it, which gets us, and this is where you have to be careful, yes, you get 1 over 3, your calculator will tell you that in case you're not too sure, but you get plus a minus, so really there should be a plus minus there as well. So you have both the positive and the negative value. Well, we also want to use our values then to find the first term in part A. So you can actually use either expression. Probably the easiest is to use the third term. So we can say that AR squared, the third term, is equal to 324. Well, r squared is equal to 1 over 9, so you've got A times 1 over 9 equals 324. So A is going to be 324 multiplied by 9, which get you 2,916. So therefore, the common ratio r is equal to plus or minus 1 over 3, those two values, and the first term A is equal to 2,916. And those are our solutions for part A. We then have to solve part B. It says given that r is positive, find the 11th term of the sequence. Well, we have both the positive and negative values there, so we can make our statement as r is greater than 0, it's positive. That implies that in this problem, r is equal to 1 over 3. Well, we know regardless of which r value that we use, that A is 2,916. And we can use these along with, because we want the 11th term, n is equal to 11 to find a value for the 11th term. Now, for this, we need to use the nth term formula. So we're going to look at U11 is equal to our A value, 2,916, multiplied by our R value, which is 1 over 3 to the power of n minus 1. 11 minus 1 is 10, which gets you 2,916 over 59,049, which isn't so nice. However, fortunately, that does simplify very nicely down to 4 over 81. This problem doesn't mention about rounding, so leave it in the exact form in its simplified form. So 4 over 81 would be your final answer there. And that's how we solve this problem.